Hello everyone. In this video, we are going to solve the problem number 1.31 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A ball starts falling with zero initial velocity on a smooth inclined plane forming an angle alpha with the horizontal. So let us first draw the inclined plane. So this is the inclined plane. This is the inclined plane which is making an angle of alpha with the horizontal, and a ball starts falling, let us say from this particular point, with the initial velocity u is equal to 0. Having fallen the distance h, the ball rebounds elastically off the inclined plane, and it is asking to find the distance from the impact point will the ball rebound for the second time. Okay, so basically the distance from this particular point where it is impacting to this particular point, it is given as h, and after rebounding, let us say it is going in this particular path and then it is again rebounding at this particular point. So it is in the problem, it is asking to find this particular length between first rebounding and second rebounding. Okay, so let us first analyze what is the velocity just before the impact. Velocity just before the impact. Okay, we know initially the ball is free falling, so the initial velocity of the ball is equal to 0, and it is having the acceleration in the downward direction with the magnitude of g, that is acceleration due to gravity, and the distance it has to travel, that is equal to h. Now from the equation of motion we can write displacement is equal to we can use other expression, that is final velocity square is equal to initial velocity square plus 2 into acceleration into displacement. So from here we can write final velocity square is equal to initial velocity is equal to 0, and 2as we can write at 2 into acceleration is g and the displacement is h. So from here we can write velocity is equal to under root 2gh. This we can remember for the general problem where we are having the initial velocity as 0 and it is free falling. Okay, now it is impacting at this particular point elastically, and the coefficient of friction is equal to 0 for this inclined plane, as it is given that it is the smooth inclined plane. Now we have to understand what is the meaning of elastically rebounding. So for that, let us say we are having a component, okay, which is fixed at this particular end, and we are applying the force. Let us say this is the deformable body. In that particular case, the length of this particular component will reduce by this amount. Okay, so basically this particular component is deforming, and let us say if we are leaving this particular force, it is coming to its original condition. Okay, after leaving the force, it is coming to its original condition, then we can say that this is the elastic deformation. Similarly, let us consider that we are having the wall and the ball is impacting on this particular wall, and let us say the general condition that it is the deformable ball. In that particular case, there will be the deformation of this particular ball while impacting, and let us say after the impact it is regaining its shape and it is coming to its original shape. In that case we can say that this is the elastic impact, and in this particular case there will no loss of energy. But let us consider another case in which, let us say this is the wall and this particular ball is impacting on this particular wall and it is deforming, and after the impact it is not coming into its original position. Then we can say that this is not the elastic impact but the inelastic impact. and in that case there will be the loss of energy. So in this particular case we know there is no loss of energy as it is the elastic impact. Now let us say that before impact the ball is having the velocity in this particular direction and the value is v naught is equal to under root 2 gh. Okay, let us say this is the inclined plane which is making an angle of alpha. So the velocity before impact in the direction of inclined plane, that we can write it as this particular angle will be 90 minus alpha. So this component will be v naught cos of 90 minus alpha, that is equal to v naught sin alpha, and this particular component will be v naught cos alpha. Okay, this is the condition just before impact. Now after impact what is going on? Let us say this is the inclined plane, and as the inclined plane is smooth, the velocity parallel to it will not change. So let us say the velocity after impact in this direction will be same, that is v naught sin alpha. But if we talk about the velocity that is normal to this inclined plane, so because of this impact the direction of the velocity will change, but the magnitude of the velocity will not change because we know that there is no loss of energy. So the direction will just the opposite and the magnitude will be same, that is v naught cos alpha. Okay, and at this particular point we know there is the acceleration due to gravity in this direction and the value is g, and this particular angle is alpha. Now from this particular point it will move in this particular path and it will rebound at this particular point again, and we have to find out this particular distance between the first rebound and the second rebound. Okay, let us do that. Let us say this is the inclined plane, and from this particular point it is the ball has the velocity in this direction and the value is v naught sin alpha, and it is having the velocity in this direction, that is v naught cos alpha, and having the acceleration in this direction with g. If this particular angle is alpha, then the component of acceleration in this direction will be g times sin alpha, because this particular angle is 90 minus alpha, and this component will be g times cos alpha. Okay, let us assume that this is the x direction and this is y direction. Now we are having the situation similar to what we have in the general projectile motion. In the projectile motion we are having the velocity component in both x and y direction and the acceleration only in the negative y direction, but here we are having the velocity in x and y direction, but we are having the extra component of acceleration in the x direction, and in the y direction we are having the acceleration of g cos alpha. Okay, so for that let us say this is the path it will follow and it will reach to this particular point, let us say A, and this particular point is O. Okay, so first of all we can see here the coordinate here, let us say it is 0, 0, and the coordinate here is L, 0 if this particular length is L from O to A. Okay, we can see here that the coordinate y coordinate here and here are same, it has not changed. So basically the displacement in the y direction is equal to 0. Okay, so we can write the equation of motion, displacement in the y direction, that is equal to initial velocity in the y direction into t plus half into acceleration in the y direction into t square. So displacement in the y direction is equal to 0. So we can write 0 is equal to velocity in the y direction is v naught cos alpha. So we can write v naught cos alpha into t minus half into g cos alpha minus, because it is in the negative y direction, so we can write g cos alpha into t square. So from here we can get the time taken is equal to 2v naught by g. So this is the time required by the ball to come from point O to point A. Now writing the second equation of motion to find the distance L, as this particular distance is in the direction of the inclined plane, that is from O to A, so we can write the equation of motion in the x direction. So we can write the displacement in the x direction is equal to initial velocity in the x direction into t plus half into acceleration in the x direction into t square. Displacement in the x direction is L, so we can write it as L is equal to velocity in the x direction is v naught sine alpha. So here we can write v naught sine alpha, and total time taken by it is 2v naught by g, 2v naught by g plus half into acceleration in the x direction is g sine alpha. So we can write g sine alpha into t square, that is 2v naught by g whole square. So from here we will get L is equal to 2v naught square by g into sine alpha plus 2v naught squared by g into sine alpha. So from here we will get L is equal to 4v naught squared by g into sine alpha. We know that v naught is equal to under root 2gh, that we have found out in the beginning. So from here we can write L is equal to 4 by g into 2gh into sine alpha. So we can get g and g will get cancelled. From here we will get L is equal to 8gh sine alpha. So this is the value of the length we got between the first rebound and the second rebound. Okay, I hope the entire procedure is clear. Thank you.